Welcome to today's class. Today we are going to see about Introduction to Fast Fourier Transform Algorithms. Contents: DFT for n-point sequence, IDFT for n-point sequence, FFT algorithm for 8-point sequence. Objectives: to revise DFT, to revise IDFT and to learn FFT. Discrete Fourier transform DFT. DFT provides uniformly spaced samples of the discrete time Fourier transform DTFT. DFT definition: x of k is equal to summation over n equal to 0 to n minus 1 x of n e raised to minus j 2 pi nk upon n for k equal to 0 to n minus 1, where n are number of points in the sequence, small n is discrete time sample at that instant and small k is discrete frequency sample at that instant. Inverse discrete Fourier transform IDFT. IDFT definition: x of n equal to 1 upon n summation over n equal to 0 to n minus 1 x of k e raised to j 2 pi nk upon n for small n equal to 0 to n minus 1. It requires n square complex multiplies and n into n minus 1 complex additions. Faster computation: by using the symmetry and periodicity property of the complex exponential, let Wn equal to e raised to minus j 2p upon n, symmetry property, Wn raised to k n minus n equal to Wn raised to minus kn equal to Wn raised to kn complex conjugate. Periodicity: Wn raised to kn equal to Wn raised to k n plus n equal to Wn raised to k plus n into n. That is, 2 length n by 2 DFTs take less computation than 1 length n DFT. That is, 2 n by 2 square is less than n square. Thus, the algorithm which employs computational savings are collectively called fast Fourier transforms. There are two fast Fourier transforms. Out of that, the first type is decimation in time algorithm. DFT can be defined as x of k is equal to summation over n equal to 0 to n minus 1 x of n Wn raised to nk. That is, summation over even samples n even x of n Wn raised to nk plus summation over n odd samples x of n Wn raised to nk. That is, summation over r equal to 0 n by 2 minus 1 x of 2r Wn raised to 2 raised to rk plus Wn raised to k summation over r equal to 0 to n by 2 minus 1 x of 2r plus 1 Wn raised to 2 raised to rk. That is, for even sequence, summation over r equal to 0 to n by 2 minus 1 x of 2r Wn by 2 raised to rk plus Wn raised to k summation over r equal to 0 to n by 2 minus 1 x of 2r plus 1 Wn by 2 raised to rk. 2r is the even sequence and 2r plus 1 is the odd sequence. DIT algorithm. Result is the sum of 2n by 2 length DFTs, that is x of k equal to g of k plus Wn raised to k h of k, where g of k is n by 2 DFT of even samples and h of k is n by 2 DFT of odd sample. Then repeat the decomposition of n by 2 to n by 4 DFTs, etc. So, this is first n by 2 DFT decomposition, n by 2 and n by 2. If we are taking 8-point sequence, then in first half we are having the samples, that is x of 0, x of 2, x of 4 and x of 6, and in second half we are having the samples x of 1, x of 2, x of 3, x of 5, x of 7, and finally we are getting the output x of 0, x of 1, x of 2, x of 3, x of 4, x of 5, x of 6 and x of 7. The butterfly structure. Cross feed of g of k and h of k in flow graph is called a butterfly due to shape. So, This is G of k and this is H of k. If we are cross-feeding the values, we are getting the shape like butterfly. So the structure is also called as butterfly structure. 8-point DITFFT algorithm. If we are taking n equal to 8, that is 8-point sequence, then we are getting the final decomposition, which is as shown in the figure. This is x of 0, x of 4, x of 2, x of 6, x of 1, x of 5, x of 3 and x of 7. This is first level, this is second level and this is third level. In third level, we are getting the output that is starting from x of 0, x of 1, x of 2, x of 3, x of 4, x of 5, x of 6 and x of 7. Summary of today's class. Thus, we have seen n-point DFT, n-point IDFT, decimation in time FFT and how to reduce the computational complexity by using FFTs. These are the references. Thank you.